Okay, so today's notes are on Chapter 9, Section 1, Mathematical Patterns. We're skipping Chapter 8 for the time being, but we'll go back and do that in a couple of units. Our content objective is to identify mathematical patterns found in a sequence and use a formula to find the nth term in a sequence. And our language objective is to use the correct terminology to describe and explain mathematical patterns. So overall, this unit is going to be on sequences and series, primarily sequences. So we're going to start by defining what a sequence is. So a sequence is an ordered list of numbers pretty straightforward. So just an ordered list of numbers, and the term, so that's the first vocab, a term of a sequence or a term in a sequence, depending on how you want to phrase that. A term of a sequence is a given number in a sequence or on a list of numbers, an ordered list of numbers. So what I mean by this, let's do a quick example. If we had a list that went something like A1, A2, A3, A4, and so on, and then we'd have n minus 1, n plus 1. So what these represent, if we had a list and these all represented numbers, this would be the first number in the list. So the first term would be A1, the second term would be A2, the third term would be A3, the fourth term would be A4, and if we continued on, this would be the n minus 1 term, this would be the nth term, it's going to be an important one, and this is the n plus 1 term. That might be a little confusing with that notation, so I'm going to do another example with actual numbers. So if we had a list with actual numbers that went something like this, so say we had 3, 6, 9, 12, 15, and that list continued on, then 3 would be our first term, because it is first in the list. 6 is our second term. 9 would be our third term, and so on and so forth. 12 would be our fourth, 15 would be our fifth. So then the notation we use for this is going to use what I showed you in the first example. So if I wanted to say the third term in this list is 9, so if I asked what is the third term in the list, or third term in the sequence, my answer would be A3, so the third term is equal to 9. So this is very much like our function notation. So I think you'll see a lot of parallels between our functions and our sequences and series when we're working, and I'll talk more about that later on in these notes. But this just means A represents a given sequence, 3 represents the term number, and then the number on the other side tells us the actual term value, or the term itself. So 9 is the term or the term value, 3 is the placement in the sequence. So I'll label that placement in the sequence, and this is the term value. So the placement in the sequence is this subscript, the term value is the actual number. So there are a couple different ways that we can represent sequences in a formula. So we can have explicit and recursive formulas. So we're going to start with an explicit formula, or an example that uses an explicit formula. So I'm actually going to flip the page for this so I have plenty of space for it. But our example says a sequence has an explicit formula. A sequence has an explicit formula. So that's one of our vocab words. It just means a formula that can be used to find any number in the sequence. So it's A sub n equals 3n minus 2. And I'm wondering, what are the first 10 terms of this sequence? So all we have to do for this is substitute numbers 1 through 10 for n and simplify. Because it's telling me my term numbers, 10 terms, are 1 through 10, so I'm plugging in 1 through 10 for n and simplifying. So if I have a of 1, it would be equal to 3 times 1 minus 2, a2, 3 times 2 minus 2, a3, 3 times 3 minus 2, a4, 3 times 4 minus 2, and so on and so forth. So if you see here, the pattern we get is 7, 10, 13, 16, and if you keep plugging these in, you're going to get 19, 22, 25, 28. So the first 10 terms, so our last step, last thing we're going to do is list the terms in the sequence. So I have 7, 10, 13, 16, 19, 22, 25, and 28. Those are the first 10 terms in my sequence. 7 is the first term, 10 is the second, 13 is the third, so on and so forth. This was an explicit formula because I could use it to find any given formula. I didn't have to use, I did end up using the previous terms to build off of it once I realized the pattern to keep building forward. But if I wanted to find the 100th term in this list, I could just plug in 100 for n and solve out and get the 100th term in that list. If I wanted to find the 2000th term in the list, I could plug in 2000 for n. So the explicit formula is a general formula to find any term in the list. So that's our explicit formula, and this is compared to a recursive formula. The other type of formula we can use to talk about sequences, and these are different because they build off of the previous term. So recursive formulas relate each term to the term before it. So what I mean by that, for example, so you saw our example of an explicit formula. Now for a recursive formula, if we had a list like 133, 130, 127, 124, and so on, I could say, if you notice the pattern, I'm just subtracting 3 each time. So my recursive formula could be a sub n equals a n minus 1. So if you remember from our previous, when I was writing the notation here, this just means the previous term, the next term. So n minus 1 just means the previous term, and I'll write that down as a definition in a second. Then a sub 1 minus 3 could be a recursive formula because it just tells you take the previous term, subtract 3, and you get your new term. You take the previous term, subtract 3, and you get your new term because a sub n minus 1 equals the previous term. A n is the nth term. A n plus 1 would be the next term in the list. So those are some just definitions because a n is the nth term, n minus 1 would be the previous, a plus 1 would be the next, just so you have that notation available to you. So the last thing I want to, or second to last thing I want to do is compare explicit versus recursive formulas. Why are we learning both of these? So first thing, explicit can find any number. So you can find any term on the list without constructing the whole list. But recursive is often easier if you're only doing a few. So if you need to find like a really large number, Explicit formulas are going to be more useful. So if you need to find like the 2000th term, explicit formulas are going to be easier. But if you're only building a 10-term list, often recursive formulas are going to be easier because they can just build off of the pattern. Build a list given the previous term numbers. So if you have all the terms you need and you only need to build out to a certain point or to a finite or shorter number of terms, recursive formulas are going to be easier. Okay, the last thing I want to mention, and I'm actually gonna, okay, I'll flip the page for this because I don't have much more room. So the last thing I want to talk about with sequences and series generally is that while what I found is sometimes students get confused about them, I just want to note that they're just like functions or in a lot of ways. So sequences are just like function equations. In many ways. The only thing that's going to be key, or so the key similarities are going to be n is just like x, a sub n is just like f of x. So again, even the n tells you what you're plugging in, an is your whole value that you get when you plug in that number. So they're very similar in that way. The only key, or one of the only key differences, is that n must be a positive integer or whole number because it represents a term on the list or a term number, or represents a spot on the A list. Or so you can't have like the negative second term on a list. That's not a thing. Because a list is a set of numbers, n has to be a positive integer because you're listing spots on the list. So you can't have the 1.5th term, you can't have the 2.7th term. So the big difference between functions and sequences is going to be that n has to be a positive integer, whereas x could be decimals or fractions. N cannot be because it must be a spot on the list. So those are the only big things I wanted to cover today. We'll learn how to build explicit formulas with sequences or geometric sequences and series. So I guess I'll mention that real quick. Two types of sequences we're learning about that we're going to learn about. So there are other types of sequences, but the two types of sequences we're learning about are arithmetic, which are like linear functions, and geometric, which are like exponential functions. So we'll spend more time building out this information more, but I wanted to highlight the key things before we delve into this unit, and we'll practice identifying explicit and recursive formulas in our note or in our classwork tomorrow. Make sure you write down any questions, comments, concerns you have on this stuff so we can go over it together in class.